it's Gabrielle, and this video is a sample from Studyclix Boost, our new rapid revision tool. Go to studyclix.ie/boost to find out more.
Hey there, it's Stephen here with Studyclix, and in this video we're going to look at calculations involving distance, speed and time. Now the minute we're dealing with a distance, speed and time question, I want you to draw your DST triangle like I have on screen. D for distance on top, speed on the bottom left, and T for time down the bottom right. This triangle will help us unlock every formula involving distance, speed and time. So let's see how it works. Say I want to find the distance something has travelled. I will cover the letter D, and here I'm left with S and T beside each other. And because they're beside each other, in maths typically, numbers and variables beside each other means to multiply them, and that's exactly what we're going to do. I'm going to say that the distance here is going to equal speed multiplied by time. And that's the distance formula. Say I wanted to find the speed formula, I would cover speed and then I'm left with a D on top and T on the bottom. So that's going to mean to calculate any speeds, I'm going to do the distance on top and I'm going to put it over, i.e. divide by the time. And similarly, if I wanted to find the time, I'd cover T for time and I'm left with time equaling D for distance on top divided by our speed. And they'll be our three formulas we're going to use throughout these calculations. So first up, we're told a train departed a station at 9:35 and travelled for 155 kilometres at an average speed of 62 kilometres per hour. At what time did the train arrive at the destination? So this question is asking us to find the time it took the train to get that far and then find the final time it actually arrived at the station. So let's write down what we have. We know that it travelled for 155 kilometres. So the value of our distance is 155 km. Then we're also told it has an average speed of 62 kilometres per hour. So speed here equals 62 kilometres per hour. Now I need to work out the time here. So I'm going to my triangle, I'm covering T for time, and I'm getting my formula to be D over S, which is our distance divided by speed. And then we're going to launch some numbers in. But before I do, I'm just going to make sure my units are consistent. My distance is in kilometres, so that means my speed needs to be involved with kilometres. And I check to say it's in kilometres per hour, so we're good. If one was in metres and one was in kilometres, we'd have to do some converting, but here we're all good. So I'm subbing in my numbers. My distance is 155, and I'm dividing it by the speed of 62 to give me a value of 2.5. And this is hours as our speed is in kilometres per hour. So we know it took 2.5 hours or 2.5 hours for the train to travel this far, but we need to find the time at which it travelled to its destination. So if it left at 9:35 in the morning, 09:35, I need to add 2.5 or 2.5 or 2 hours and 30 minutes onto this. So adding 2.5 hours onto 9:35, if we count up on our clock, we will get 12:05 as the arrival time. So you can see what we did here, folks. We wrote down what we had. We had D and S. We were looking for time T, so we wrote down our formula, subbed in our numbers, and got our answer. Let's try another one. I'm told a person travelled at an average speed of 72 kilometres per hour for 4 hours and 20 minutes. How far did they travel correct to the nearest kilometre? So let's write down what we have. We have the average speed. So I know S here is going to be 72 kilometres per hour. And I also have the time it travelled. T here is going to be 4 hours and 20 minutes. And we're asked how far did they travel. So we're going to be looking for the distance here. And I'll cover D in my triangle and say that our distance here equals our speed times time. However, before we launch our numbers in, I'm going to look and say that our time is in mixed units. It's in both hours and minutes. And I want to combine it into just hours because I'm looking at my speed, which is just in terms of hours, kilometre per hour. So I want to combine 4 hours and 20 minutes into hours. Now there's loads of different ways to do this, but I'm going to show you how your calculator can do this. All we're going to do here is use our degrees, minutes and seconds button. So I'm going to type 4 for hours, then I'm pressing my degrees, minutes, second button to get a wee box which represents the hours. Then I'm putting in 20 and I'm pressing the degrees, minutes, seconds button again here to get minutes. So I have 4 hours and 20 minutes typed in here. And if I press equals, 4 hours, 20 minutes and 0 seconds pop up. But if I press my SD button and change it, that's going to be 13 over 3 whole hours, or 4.33333 hours. And it makes sense that 20 minutes is a third of an hour, so we're getting basically 4 1/3 hours here. Now, I'm not going to write the decimal. I'm going to change it back to the fraction of 13 over 3 just to keep it all together. So I'm going to say t here is also equal to 13 over 3 hours. Now I'm going to launch everything into my formula. I'm going to take my speed of 72 and times it by 13 over 3. And when I work that out, I get a big long decimal of 16.615 ... kilometers. And I'm reading the question and I'm saying, how far did they travel correct to the nearest kilometer? Well, I'm going to round that up to 17 kilometers because the 0.6 tells me to do so. So there we have it. They traveled 17 kilometers. A big thing in this part, folks, is changing the mixed units into a whole hour by typing it into our calculator. And let's look at one more. I'm told the time taken by Jack to travel from Derry to Waterford, a distance of 378 kilometres, is 6 hours. His return journey from Waterford to Derry by the same route takes an extra 45 minutes. We're asked in part A, by how many kilometres per hour is his average speed slower on the return journey. So we've two journeys here. We've got Derry to Waterford, D to W, and we've also got the return of Waterford to Derry. Both of these, I hope you'll agree, have a distance equaling 378 kilometres. So I'm going to note that down. And the time for his first journey, Derry to Waterford, takes 6 hours, so t equals 6h. But then on the return, it takes 6 hours and an additional 45 minutes, so 6 hours and 45 minutes. And then what we're asked to do is find by how many kilometers per hour is his average speed slower on the return journey. So we need to find the speed here for both journeys. So I'm consulting my distance, speed and time triangle. I'm covering S for speed, and I'm going to say my speed here equals my distance divided by time. And then I'm going to launch numbers into the formula. But before I do that, I'm looking at the return journey and saying that the time here is in mixed units. It's in both hours and minutes. Now look, I know most of you will know that 45 minutes, as we say, is 3/4 of an hour. So we could change this to 6 3/4 hours, or 6.75 hours. But I just want to show you that the calculator will do that for you as well. If we again type in our 6 and our degrees, minutes, second button for hours, and 45 and degrees, minutes, seconds button for minutes, press equals, press the change button, we get 27 over 4. Press change again, we get 6.75, and that changes it all into entire hours. So our 6 hours and 45 minutes, we're changing it now into 6.75 hours. Then we're going to sub the numbers in. I'll calculate the speed for the way there. So distance 378 divided by time 6 gives me a value of 63. And we're dealing with kilometers here and hours, so it's kilometers per hour. And on the return journey, we're looking at our speed again. Same distance of 378 on top, divided by our new time of 6.75. And when we whack that into the calculator, we get 56 kilometers per hour. And then we look to answer our question and say by how many kilometers per hour is his average speed slower on his return journey. So if it was 63 on the way there and 56 on the way back, it was slower by a difference of 7 kilometers per hour. Now it's your turn to try this out. Pause the video here, work through these questions and check in with the solutions when they appear on screen. Here in question 1, we're working with our 3 formulas. Just be wary in part A that you convert that time into single units of hours. In question 2, I hope you can see in part 1 that we click that the time taken was 1.5 hours or 1.5 hours. And in question 3, we're still working with the same formulas, but we're using gigantic numbers. But don't let that throw you because your calculator does the hard work of that. Thanks for watching.